What's good, guys? This is 4.5 part 1. Let's go. Miss Leg said this is gonna be an easy lesson for some reason. I don't know. Ka-chow!
The reason being that I'm going to teach it so well that you're going to understand it. Just kidding. It's going to be a little bit harder than yesterday, but I think yesterday you guys did understand those inequalities and the shading and the dashed and the solids. Now we're going to do systems of inequalities, which is where you take two inequalities, they join together to form a solution. Just like when we did systems of equations being with an equal sign, systems of inequalities, up here please, thank you. Systems of inequalities have two boundary lines and they're shaded all over the place, and we're gonna see what solutions there are with inequalities. Let me give you a hinty hint. When we had systems of equations that intersected, how many solutions did that system have? Oh, that would be this. Yes, you were kidding, it was a joke. It had one solution. Now, picture these same lines as an inequality, systems of inequalities, with all that shadiness. Do you think there's going to be one solution or more than one solution?
More than one.
What do you think it's going to be based on?
Where the shade is.
Where all the shading is?
Yeah.
Or where
Where's the shading overlap?
where the shading overlaps? Did we talk about this already yesterday?
No.
You guys are just a bunch of geniuses?
Yeah.
Okay, that's what I thought. All right, this is technically a do now, but we're going to do it now together. Head up, pencils in here. You okay? Not so much. You need a break?
Yeah.
Guys, if I'm talking to us, do you need to all turn your heads? If you need a break, you can get a break. When I said nobody could go to the bathroom, I meant everybody else. You need to step out there. Especially you. Ooh. No, it's not, it's nothing to do with that. You just can't leave my class because it's so fun and interesting.
And
I
also
wouldn't
so
want
hot in here.
I wouldn't want you to miss all the fun.
It's also so hot.
It is very hot in
Or
here.
milk.
Okay, so let's focus. We'll get through it together. Before we get into all this inequality craziness, let's go back to our systems of equations. I even have my matching markers to keep everything nice and organized. Let's go back to simple old systems of equations. If these two equations are part of a system, that means they're going to have how many solutions?
One.
One solution, as long as they intersect, which they have shown here that they do intersect. What that solution is, oh gosh, I could probably estimate it, but it does intersect in the middle of a square, so I'm not even going to try to guess what that solution would be. But we do see that you can simply graph the line based on the y-intercept, -1, and the slope 1/1, and then graph the other line, +4 as your y-intercept, a slope that is -2/1, -2, +1, -2, +1, and they do intersect. And that is solving a system of equations by graphing, which was lesson 1 from this topic. Yeah.
So when you go down to right one, it wouldn't intersect. It lands on the x-axis. Because
So this intersects the x-axis, so it has an x-intercepted too. But the solution to the system, which is the red and blue lines, is right here. It has one solution. I don't know what the coordinate pair is exactly. It's probably like x is 1.7 and y is 0.7. I don't know. It's just weird. I'm not even going to try to guess, okay? Even though I just did. So let's pretend that this system of equations is now turning into inequalities. Inequalities. That's going to involve some shady business, right? It's going to get shady in there. Before we start shading everywhere, let's take a look at this first line, y equals x minus 1, this red line. Choose some points above the line and below the line. And then we're going to examine those points a little bit. So somebody give me a few points above the red line.
2, 1.
2, 1. Okay, that would be on the red line.
That's 2, 2, my bad.
Let's do 2, 2. Okay. Yeah, can you give me another one?
4, 4.
4, 4. Good.
1,
1, 2. Yeah. It's okay that it's going through that blue line. The blue line doesn't exist to us right now. We're just talking about the red line. Okay, so give me some points that are below the line. Uriah?
0, -4.
0, -4. Okay.
-1.
-1, +1.
No, negative, a positive one.
What? +1, -1? Okay. +1, -1.
2, -3.
2, -3. And we could continue all day and just keep naming coordinate pairs. And you guys would be like, yay, this lesson was so easy. But we can't just keep naming coordinate pairs. We're gonna take these two areas of coordinate pairs, the one above the line and below the line. Tell me which group of them, the ones that are above, whoops, or the ones that are below, which group of coordinate pairs would be a solution to this inequality. It's the same equation, same expression, just instead of an equal sign, it says greater than. Charlotte.
I was gonna ask if you can write the steps on the board,
Okay.
if there are any.
Yeah, sure, we can do that. This is more just hey, let's think out loud. We're not actually solving anything. We're just hey, what would it be like if we did this? But keep reminding me of that because that is a really good way to get you guys to write the steps. I kind of usually say the steps verbally, so I sometimes forget to write them, but yeah.
Can I give you? The,
Yes, I forgot my question.
The bottom ones.
So the bottom ones are gonna be solutions for this one.
Yeah. Because the y just up to negative.
Oh, you silly, really?
He forgot everything from yesterday.
Oh, it's greater than.
It's greater than, right. We look to the inequality symbol. It's greater than. So we know that everything above the line is going to be a solution for that inequality, right? That's why we shade above the line, because it covers all of the coordinate pairs, not just a few that we select. But let's just go ahead and grab a couple of them. So this would be 1, 2, right? Let's do this one. 4, 4. And let's just make sure that it is a solution to this. Okay, so 1, 2 would be here, greater than 1 minus 1, 2 is greater than 0. Is it true?
Yeah.
Good. And then 4, 4, so 4 is greater than 4 minus 1. Is that true? Good. So we can go ahead and assume that all of the points above the line, and I should probably dash this line just because.
Yeah.
Did you say yeah? He's like, yeah, should have done that already. All right, I'm gonna dash that line. I don't know why the book doesn't. It's funny. Okay, because there's no or equal to sign, I went ahead and dashed it. Yeah?
It's really
All right, I'll call front office.
So where do we shade?
It's a good question. Where would we shade if we wanted to shade for that inequality, the one that's in the box? Well, which group of points worked for the solution?
The top.
The ones above the line or the ones below the line?
Above.
Hello, would it be possible to tell maintenance to make it 1 degree cooler? It's Mrs. Lake, the one who has the hot room. Thank you. Yeah, okay, so Brianna. We were just proving that these dots are the ones that make this true, which kind of verifies the lesson that we learned yesterday, where the greater than symbol implies that the points above the line are the solution. So therefore you would shade above the line
Are we
for
just talking
this.
about the red line? Or we just
Yeah,
talking
we're
about
just on the red line right now. We're pretending the blue line doesn't exist. So we would shade it above the line. Now, the points that we grabbed below the line, do you think that they're gonna be solutions for this one then? What do you guys think?
Yes.
Do you think they are? Do you think these points will be solutions for this one then?
Yeah.
Maybe.
I think so. Let's take this one, 0, 4. So if x is 0 and y is, I'm sorry, 0, -4, -4, -1, -4 is less than -1. Is that true?
Yes.
Is that recording? Did I ever press record? I think I did.
Yeah, you did.
I just have a fear that I'm gonna get to the end and it's not when I've recorded this wonderful lesson. So this is true. We can grab another point just in case. 2, -3, so that would be 2 minus 1. -3 is less than 2 minus 1. -3 is less than 1. Is that true? Yeah. So that just kind of verifies the lesson that we did yesterday, where the inequality that says less than, all the solutions would be below the line. Does that make sense? It's just what we learned yesterday. Okay. Now let's go to our blue line. And I'll go ahead and dash it because it's again going to give us the one that is not or equal to. What?
The length
The
of the
sweeping? Oh, okay, sorry. Okay, you would. Choose some points above and below the line. Above and below the line. And see which ones are gonna be solutions to the greater than, and which ones are gonna be solutions. Lex, it's not that exciting. No. Which ones are gonna be solutions to the greater than, and which ones are gonna be the solutions to the less than? Yeah, just go that way. So let's grab some points. Let's grab some above the line. Anybody wanna name some coordinate pairs that are above the line?
4, +4.
Okay.
That's technically a
Yep.
3, 2.
3, 2. Okay. Whatever works. Okay, whatever works. He's wide awake. Okay.
5, 3.
5, 3. Love it.
No, he chopped it.
All right, so we've got a bunch of points above the blue line. There are so many more, but we don't have that kind of time today.
Oh.
So we are going to just plug them in to this first equation. Do you think it's going to be true or not true?
True.
Yeah, there'll be solutions for this because this is a greater than,
It's above.
and it's above the line. So let's just take it and double check. Y is greater than -2x plus 4. And let's take this one. 3, 2. Let's just do 1. Okay, so the 2 is the y, -2 times 3 plus 4. And we've got -6 plus 4, which is -2. 2 is greater than -2. Is it true?
Yes.
Good. Do you want me to do the other points or have we
No.
kind of proven the point? Get it? So, if these are points that are the solution, that are solutions to this inequality to the greater than one, it proves that when we shade above the line, we are shading all of those coordinate points, even the ones that are like the decimal combinations, like x is 4.987 and y is 1 point, I don't know, whatever. All those crazy tiny little ones, okay? Now, again, if we look to the one that's less than, where is it gonna be shaded? Below the line, and all of those coordinate pairs would prove this to be true. We good?
Ding, ding, ding.
So that was a little bit of a review from yesterday. What would this graph look like if we join these inequalities together as a system? And I'm going to rewrite them, I'm gonna make up my own inequality symbols. So the first one, I'm gonna do y is greater than or equal to x minus, oh wait, I wanna do that in red. Y is greater than or equal to x minus 1.
That's, the symbol's wrong. It's this way. Is the symbol not that way? It's the on A.
So I just said I'm gonna make up my
Sorry.
own symbols, yeah.
Oh. Will they give you that, the symbol that you have to?
Oh, yeah.
Okay.
Oh, always, yeah. So, and then my blue one, I'm gonna do the same, everything's gonna be the same, so I'm gonna make up my own inequality. I'm gonna do y is greater than or equal to negative 2x plus 4. All the variables and numbers are the same. I just chose some inequality symbols and I want to do some shading and see where the solutions are. Okay, we're gonna go on a solution hunt. First, let's shade according to this. I chose to do or equal to signs so that we could just use these solid lines, right? Okay, so how would we shade the red? Yeah, above. Okay, how would we shade this one?
Or no?
Above.
Above.
They merged with each other.
Wait,
They made purple.
Made purple.
Oh my god.
Oh my goodness. So, where's the solution to the system?
It's in the purple.
It's in the purple. It is this beautiful triangle right here that extends out forever. So all of these coordinate pairs, forever and ever and ever, as long as they are in between these two lines and don't include anything else, these are the solutions that will work for
Any.
Everything.
Wait.
The other one. The solution.
Every
What's the question?
answer.
these coordinate pairs will work for what? Will
The
make
solution.
what? Both of them. There we go.
Go away.
Don't make it a bigger deal than this. Just say thank you and move on with your life. Okay.
I think Bosch is super happy.
I have a
Okay.
question.
So,
Why is this one different from the other one?
what other one?
The last one, when you just multiplied it or equal to?
Was the last one what?
The last one, how it doesn't have the equal part of it. But why does it look different?
What looks different? I'm sorry, I'm just trying to figure out which one you're comparing it to. We've just been working with like different ways to shade based on
this is the
inequalities.
first one, okay.
Yeah, so let's prove that something in here will work for both of them. Let's take 2, 2. How about that? It's right in that triangle. So 2, 2, let's see if that would be true. 2 minus 1 is 1. 2 is greater than or equal to 1. Is it true?
No.
Good. Better work in both of them or else I'm out of a job.
Uh-oh.
Uh-oh.
Uh-oh,
Can
spaghetti.
you imagine? -2 times 2 is -4, plus 4 is 0. 2 is greater than or equal to 0, is that true?
Yes.
Okay, good, I still have a job. Okay, so the solution, which will be found in the shaded area, will make both inequalities in the system true. Tell me what would happen if I tried to plug in a coordinate pair from this red shaded section. What would happen?
Well, it wouldn't really work like the system would come out right.
Okay, can you be more specific?
It gives that one definition for that one line.
Okay.
It would only solve the red one.
Yep, it would only make the red equation true. It would not make the blue equation true because we can see that all of the blue solutions are here. So it would make this one false. What if we tried to grab a point here in just the blue shaded section?
Yeah, it'd be the same thing about all the blue.
It would only
That's why I got
make the blue inequality true and the red inequality would end up being false. If they're going to work as a system, they can only have solutions that will work for both of them. And then obviously if we pulled from something down here, what would happen?
Nothing.
Whoa, nothing.
It would make both of them
It would
false. Yeah, it wouldn't work for either one of them. So that's pretty much the whole lesson, but I'm going to go over, I know I did that with all the do now, but I'm gonna go over some examples with you.
Example.
And I'll do step by step. Skipping, skip these.
Skippy.
Okay. I want to look at parallel lines for a second. Now, again, this isn't a step-by-step solution. This is just, hey, let's look at it and interpret what's going on. So, do you see these parallel lines here?
Yes, I think so.
These parallel boundary lines for inequalities. Generally, if we are talking about parallel lines in a system of equations, what's the solution? No solution. That was quick. We were like, there's a solution. There's no solution.
What?
That's why parallel lines are arguing all the time.
Because they have no solution.
Now, take a look at these parallel linear inequalities. They're getting all shady. This one is shaded above the line because it's greater than. This one is shaded below the line. Is there a solution?
No.
No. So does that mean that parallel systems of inequalities that are parallel lines will never have a solution?
No.
Yes.
Are you
See.
hearing no and yes?
See, they will never find a solution.
He wouldn't be showing us.
Speak, Uriah.
If that one is less than or equal to, it'll go through that.
If this inequality had a different symbol,
Then yes. They would.
then the shading would be in the other direction. And then suddenly parallel lines that disagreed for so many years would then find a solution spot right
Right there.
here and of course
That's what we call frenemies.
what?
That's what we call frenemies.
Frenemies. It's like they almost never get along and then like they sometimes just have some things in common. Okay, so parallel lines that are inequalities sometimes will have no solution and sometimes will have a solution. It just depends on where the shading is. And the shading depends on what the inequality symbol is. You guys get it? Okay. Now I want you guys to try to graph these systems and show me, hold on, you guys are talking and I haven't finished my sentence. Two things. Number one is I want you to try this on your own, but I will go over it before class ends and show you the steps just in case you are having trouble on it, okay? But I want to give you guys an opportunity before before we do, I want to give you some tips. This one's pretty straightforward. This one is missing some information, right? What information is this one missing? Y-intercept. What's the y-intercept? Good. This one's missing some information.
The x.
Yeah, it doesn't have a slope.
So if x is 1.
And then, does it have a y-intercept?
No.
No,
Yes.
That means
The y-intercept is
0.
-3.
Oh.
it's just vertical.
So then
So it's on, you're thinking vertical because of the y-axis, but the y-intercept is 3, which means y will always be -3, at least as a boundary line.
Oh yeah, it's the intercept.
Yeah, it's the intercept. It would be a boundary line that is a dashed horizontal line, and the shading would be based on the inequality. Do you want me to go over A with you step by step, and
No.
then you'll
Negative.
try B on your own?
Negative.
Please have a ruler.
No, wait, you should go over B step by step and let us do A by ourselves.
Why? Because I already did part of A?
No, because A's easier.
Why'd you say that?
No. This one gives you more information. I'm gonna go over A.
Can you give me a ruler for this?
Step 1. Graph the points of the line. If there's no y-intercept, it's 0. So it's going to be right here. So I'll just do this. First, the y-intercept. Then use slope to plot next point. Okay, is that good?
See.
All right. So I'm going to use the slope, which is 2x, not 2x, it's 2, which is 2 over 1, up 2 over 1. I'm just going to go ahead and continue just to get my line like really steady. Now, step 2. Before making the line, check the inequality to see if it should be dashed or solid. Equal to solid. No equal to, I should say, or equal to would be solid. No or equal to would be dashed. This one has no or equal to, so I can connect these dots as a solid line. Step 3, shade according to, shade according to inequality. Greater than means above, less than means below. This one says less than, so I'm going to shade below the line. Yeah,
Why isn't that line dashed?
because,
There's no equal part.
oh, that's weird.
You did.
Why didn't anybody tell me?
I thought it was like that.
It's not, this isn't supposed to be a solid line. It's easy to dash with dry erase marker. though.
Silly Willy.
So I have a candy?
Of course.
In an
You like
alternate,
these?
I can't.
in an alternating universe.
These? Okay, so now that's all good. Now let's do our next one. Yeah?
Do I get candy for doing the
Two.
Huh? I don't even know what he said.
It wasn't too used to me. You're easy now.
Down on the ground.
All right, y is greater than -3. We already talked about this. The way I think of this is y equals -3. That helps me get where my line will be, but then I check my inequality to make sure that I dash it if it should be dashed, which is correct. Do you want me to write all that out? This is like a kind of a
Is it that?
unique situation. This would be dashed. If y equals -3, that means the y-intercept is -3. And there's no slope. There's no x term. So that means it's a horizontal line. It doesn't go up or down. This is a horizontal line because y always is -3 on the boundary line. Does that make sense?
So it changes? Like
What
the,
changes?
Alligators, I forgot what they're called.
So we haven't even worried about the shading yet. I'm just graphing it as if it just says y equals -3, but I made it dashed instead of solid. So the fact that it's a horizontal line has nothing to do with the inequality. I'm pretending that it's y equals -3. Because if it says y equals -3 and there's no x term, it means it's always -3. It has no slope up or down. So I dashed it because of the inequality, and then I'm going to shade according to the inequality, just like from those steps. So I'm going to shade it above. Where's my solution?
Right there.
The purple.
The purple. Yep.
Purple?
This whole
Or-
triangle right here. But be very careful because everything's dashed in this one. So just keep in mind that none of the points that are actually on these boundary lines will actually make it true. They're not solutions. Those are just boundary lines saying that everything inside of this area is the solution. So the answer to this question is literally by the shading. That's how you'll answer your, well, you don't have homework for 4.5? What?
You said that y'all was gonna answer.
Oh, did I say y'all?
Yeah.
She does.
Oh.
That's how y'all.
Okay, so I want you guys to do B on your own. You already do it? Okay, let me get my book. If you get B right on your first try, before you show it to me, just make sure that your lines are dashed or solid according to this. There you go.
It was already down.
Oh, it was?
I'm trying to
Okay.
make it clear.
I want you guys to do B, yeah,
I have a question.
okay.
So,
Yeah.
okay, that's what I thought. Thank you. That's what I thought.
You guys have about 5 minutes. Just do this question. So really look at it and make sure.
Can I have a ruler?
No.
Actually, yeah, I can get it.
It's okay. Can you pass it on to anybody else? You want me to look now or are you double checking?
Who would like a ruler?
You done? Okay.
No. Oh, you got Skittles?
Looks good.
This one's got the good stuff. Oh, wait. I messed up. $100 each?
No, thank you.
Are you guys gonna work on B? Okay. Okay.
It's $100 each.
Sit and work.
Oh, okay.
Only the one?
You got told.
I gave you one, man. Yes, I did. Oh no, I gave Lex one.
Yeah. What? Graphing and shading. Make sure your lines are dashed or solid based on the inequality.
Just load. I think I got it. So this is the top.
No, your lines are not right.
Oh.
It looks like your dashed line is correct, but your other line.
Huh?
your
I
other
think
line
Vincent wants to purchase a
is
ruler.
negative.
You'll purchase a ruler, young sir?
Oh. I mean, alright.
You read it.
I'll purchase a ruler.
You know what? They think it's not $16,000 value.
I got you right here.
What?
Right here.
Here,
17,000.
18,000.
Two. Well, it's like, bro, that's a 2 quarters.
Wait, I made two lines different. Oh, you're different rules.
Well, yeah, because there are too many lines.
Okay.
Just like I got it.
You got it?
Just like, that's just it.
Then you reach up there for the
You better tell me.
Something like this.
No, that's not it.
I got it.
that's not right. Okay. So we're gonna
It's something like that?
just
You got
a regular line.
Not like
For the
that.
second one?
So let's look at the first one. What's the 9%? 1.
Here,
So 9 is 1.
Okay.
So that's on the straight line right here.
And there's
Miss Love.
Okay.
And then-
Where's your y-axis for the?
I got it. I just accidentally.
What's this one?
Okay.
Okay, what about this one?
Right here. It's like, it's all.
Am I right? Oh my god. Just kidding.
No, that.
I gotta check them all. I gotta make sure.
I get one.
It's okay.
It's alright, it's alright.
No.
Okay, look at your inequalities. For your top one, it's greater than. So look at the notes. If it's greater than, it's. Here you go. Look at my notes at the very bottom.
This is what I said. It's called.
Yes.
Good view.
Looks good.
This line
So
almost.
that's an incident. Oh.
So, first one. Y-axis is positive.
Right.
You need to make a better
I need to go, let me borrow this.
Well, this one belongs to that.
Which one's
Party?
You're still recording.
They're both?
Oh, that's okay.
No, both of them.
Okay.
So like, just shade about both more.
I have a question. Can I have a question?
Okay, and it's -2 and 2x.
Yeah, sure.
Where's the marker at? Yo, I found it.
Well, when the slope is just like this, then only the
Your
two.
dash, your dash line should be south.
Yeah, I did it already.
Because
This line.
Brown hat.
or equal to one is what should be.
It's not a step of the tree. You know, she's black. It's a red. She's black.
Is this dash?
No.
Yeah, get that right.
It'll be just one of them. Since it's just.
Most sharks are so hard.
So it'd be very good. So what's the solid base?
Bro.
No, since the one is Does it work, sir? Does it work?
Okay, this leg, I got it.
Good job.
Miss Lake, I got it.
I helped him.
Jacob, help me.
I got it.
It's gonna be a.
So if it's right, Jacob can get your candy.
Yo, I'm a better teacher than you.
What?
He's not wrong.
You should revoke his hand.
So this is the dash.
I did it though.
This is the
I did a good job though.
dash line.
This is fun.
So it's on the
You got 1 second extra.
This is the
Can you like, wait, is that like dash or something?
this is dash.
Okay, so why is it dash? I told you, if you were able to explain these dash, I would have been.
Oh no, it's because the greatest